And the third Tuesday, we have our section meeting. And that section meeting has a lot of different people come on and speak and present. And there's a lot, it's usually very interesting, especially your field.
All right, we are now on YouTube.
If you would like to come and speak, we would love to have you.
All right.
People who speak to their profession and their experience or something they're working on that is unique. We'd love to see you there. Is that it? Here we go. Now, I don't use this caliber, but
We also
it is getting.
items for tonight.
So if you, are you on this at all?
I'm not sure if Rich, the other Rich, will be here to say something about elections.
That time of year.
Yes.
Well, our elections, not the other ones. That we can't wait for that to be over.
No, I know our
My
the
phone
Belmont
stops
elections,
ringing
too.
and
Yeah.
The only good thing about the elections is the commercials are drowning out sort of the Camp Lujan or whatever it is.
oh yeah.
And
They're drowning out the psoriasis commercials.
Oh, that's true. Yeah.
to get your membership.
I don't have my psoriasis fix.
But we have that available to you, and I don't think.
You ever listen to the contraindications at the end of those commercials?
Oh, my God. It's
Yeah, I
great.
don't know why anybody takes anything.
Yeah. I'm sure Steve can weigh in on that, but I always like, psoriasis. Oh, by the way, kiss your liver goodbye.
Yeah.
I'll take the psoriasis.
Right. The one I like is if you're allergic to this medication, don't take it. How do you
Right.
know if you're allergic to it, you know?
Your emails with IEEE. It's growing.
You'd be surprised the number of people who know they are allergic to something. And after whatever period of time, they say, well, I'm having whatever, and this medicine's for it. I'm going to give it a try. I still have it in the closet. And then they come in and they have another reaction of some sort. I don't like to use the term allergy because most of them are not true allergies, but they are adverse reactions of various sorts.
Yeah, I guess some people don't learn.
Well, it's not just with respect to medicines, but I won't go further with that.
Okay.
All right. Well, it's 7:15. Maybe we'll get started. So welcome to the October 2022 meeting of the Mid-Atlantic Amateur Radio Club. I'm Jeremy N2ZLQ. So as we normally do at the beginning of a meeting, we will have a round of intros. So give me your best pile up.
Good evening.
Blue WX3I.
Dennis, K3DS.
Rich, AA3RC.
Steve, K3FZT.
Jim,
Ron, KC3ACL.
Karen, KC3ACM.
Jim, W3JNF.
Bob, N3JIZ.
Dylan, KE0VIS.
Get everybody?
Well, there's Ned, but he's in a noisy spot.
He's in a meeting.
Yeah, he is making the machine. He's very making the machine tonight. All right. So let's see. First order of business, treasurer's report.
Okay, right now we have $18,926.76 in the bank. I have not yet paid for the people who bought food for the QSO party, mainly because I didn't write their call signs on the receipt. So I'm going to have to hear from people who need money. And I'll get it out to you as soon as possible.
Yeah, I think Peter was the main one who bought food.
Yeah. And then I think Ned did too. So, but I'm not sure. So, if you did buy food or buy supplies for the QSO party, let me know. And I think if I have your receipt, I'll just make sure I pay it. Otherwise, get the receipt to me. And we currently, we've added a couple of people to the list. I have not put out a new list, unfortunately. But we're up to, I think, 83 members now.
Okay. All right. Thanks, Lou. Let's see. I'm kind of going in calendar order here. So how about public service? Bob, you want to give us an update?
Okay. Yeah, we've got 2 public service events coming up. The first one is the 5-mile Radnor Run. That's going to be on this coming Sunday. I believe it's this coming Sunday. Yeah, this coming Sunday, October 30th at 7 a.m. And they're looking for probably about 9 or 10 people to help out. And so from our standpoint, that means we probably, to really do a good job, we probably need at least 15 people to help out. So we're definitely looking for people to sign up or show up or help out with the event. So I will try to get an email out to the membership tomorrow. I've got a day off tomorrow. Took a vacation day tomorrow, and so I'll try to get that out tomorrow. And let's see. I guess the next event is the Vietnam Veterans 5K run, and that's Saturday, November 5th, rather. Saturday, November 5th at 8 o'clock in the morning. And we'll be meeting at the Norristown Farm Park in the picnic pavilion, which is roughly in the center of the park. And this is a little bit of a shorter event, but we're also starting a little later. But as it turns out, for both events, we'll get home for lunch. So it'll be a real nice morning for both events, hopefully. I'm hoping that it's not going to rain for the Radnor Run, but who knows how that's going to turn out. And anyway, the Radnor Run is a little more challenging RF wise, propagation wise, but they're both very easy events to do, and you'll be pretty much with your car all the time, so you won't have any trouble. All except the person at the start finish will be with their car. Let's put it that way. And so anyway, there's our 2 public service events, the last ones of the 2022 public service season. So be there or be square.
All right. Thanks, Bob. All right. So on November 5th, we're actually double dipping that day. So in addition to the public service event, we also have a VE test session. That'll be at the Lower Providence Township Building, which is 100 Park Lane Drive in Eagleville. And that starts at 9:15 a.m. So that's November 5th. On November 12th, we're going to have our next club breakfast, which is usually on the second Saturday of the month. And we're actually going to be trying out a new location this time, which I think will be a little more responsive to our needs. We're going to meet at Andy's Diner, which is on Ridge Pike in Conshohocken. It is right off the Blue Route, the Ridge Pike exit. Did anyone want to say anything about the breakfast, the new location, or any comments about that?
Well, I'll have to get to the webmaster. It looks like he screwed up in the chronological order because he's got November 5th after November 22nd, but so what? It's on the calendar, but
All right. Yeah, I just noticed that. Okay.
I'll fix it.
All right. So actually, while we're at it, Dennis, did you want to give the technical services report and holiday party?
Yeah, sorry, I missed my turn. I'm double dipping. I got another computer running another meeting across the room. Let's see, technical report.
Doing well. Given and discussed.
The Darby repeater will be going online.
They won't
God willing, and Steve can help me most probably sometime next week. I'm clearing my calendar. We actually did not get some research money coming in, so it looks like I'm going to be free for about the next 6 months. So I guess I should get that done. In case you don't know it, that's basically the 2 meter and 220 linked repeater, and I was mentioning before the meeting start, 444.050, which is a fusion site, and now hooked up to the Pennsylvania wide area net. Seems to be somewhat active, except everybody comes in from the West Coast, from out by Pittsburgh, and they're surprised to hear Philadelphia. So that's good. The holiday party is December 5th. It's a week earlier, same location, but a new date due to availability. I have to get around 20 to 25 people to sign up, or we're not going to get the back room. And I don't think it's worth just having 2 or 3 booths and everybody stand up and talk to each other or whatever. So right now I've got 6 people. So I'm going to get out another email blast, because that has to be tied down somewhere around the middle of November. I think they'll be probably calling me. But if we can't get that we'll have to, it's going to be a financial penalty, and they may not even want us. They'll probably go to the second one on the list, I guess. So we'll try and see what happens. And that's the report.
All right, thanks, Dennis. Yes, that'll be great. We'll have 147.36 back on air. That's been down for a little while due to technical issues, and we'll get 224.5. That's been off the air for quite a while. That repeater, I think, failed sometime around COVID, and we haven't been able to get back in there. So that's going to be great having that online, and having 444.05 connected to Fusion, thanks to Steve, K3FZT. All right, let's see what we've got otherwise in here. Did want to say a little bit about the PA QSO party. So we had that about 2 weeks ago. Actually, I do have a score report. Dennis put together the score and submitted it to the organizers. So we have from our club station 215 contacts. That includes 84 multipliers. We have 55 out of the 67 counties in PA, and a claimed score of 23,100. So then in addition to that will be any home stations who submitted their own scores. I know Herb did his own station. I think he was somewhere in the 20,000 range, and probably a couple of others will put their own scores in. So I guess we'll have to wait to see what the organizers come up with. I think last year it took them a while to get the scores together, but hopefully it'll be a little faster this year. So thanks all to those who participated in the PA QSO party. I thought it went very well, so I'm looking forward to having that as an event next year. So let's see, elections are ongoing. I don't see Rich, KB3VZL, but he's running the elections this year. So pretty much all positions are open. So if anyone's interested in running for any positions, let Rich know, and he'll get you on the ballot. So the ballot should be coming out at some point in the near future. Nominally, we wrap up the elections at the November meeting, but if we have to run a little bit later, we'll do that. We do have to get them done by the end of the year, though. Okay. Are there any other comments for the club? Any other committee reports? All right. So with that, we'll move to the main presentation of the evening. So this was a popularly requested program. So Lou, WX3I, in addition to being our treasurer, is also very active in weather forecasting. He's very active in training out of the Mount Holly office of the National Weather Service, very active in Skywarn and several other things. So Lou is going to tell us tonight about weather forecasting. Maybe a little look kind of under the hood, or a little of the sausage making, if you will. of how weather forecasting works. So take it away, Lou.
Can everybody see my screen?
Yeah.
Yes.
Okay, great. For a presentation like I'm doing tonight, I can't go into too much detail about a lot of stuff, but I'll try and cover some stuff and try and make it interesting. So we'll get going here. I did put together this quick agenda and basically sort of at a high level, sort of go over what the different climate zones are. There's actually a lot more than those four, but those are the four main ones. Atmospheric scales, because what scale you're looking at, the atmosphere determines how much you're going to be able to forecast, et cetera. Also, in the temperate zones, which is where we are, I think everybody here is in this area. A little bit more about what the weather phenomena are in the temperate zones, and you know, how you actually like monitor that stuff, and actually a little bit about how you forecast it. And then we'll go to the tropics, because one of the popular requests was, you know, what's going on in the tropics, what you know, how are those forecasts done, and what is that darn cone? I mean, that was one of the questions. So we'll go over some stuff about the tropics, and just a little bit more about how the tropical forecasting is done around the world, and what some of the National Hurricane Center forecast products are. So the four main climate zones are polar, temperate, subtropical, and tropical. So the characteristics of the polar zones are basically generally cold, long summer days, short winter days, and home of the polar vortex. That famous favorite thing of broadcasters a number of years back about explaining why it got so cold around here one time. Polar vortex is always there. It's just that when it gets weak, that's when it sort of like pushes down into the into the temperate zone. So that's really what's going on in the polar region. The temperate region, again, that's sort of where we are. Basically, you're going to get a wide temperature difference. You're going to get basically four seasons in most of the temperate zone. Larger weather systems are moving west to east, so you'll see a storm that might fire up in the Rockies, and it'll actually move west to east towards us a lot of times. Good thing is weather models actually handle the temperate zone well, and that's because the temperate zone is where most of the people live, and so there's a lot of data that they can get from a bunch of weather geeks and stuff that help them to feed the weather models and get them to initialize better, and basically be able to handle the weather in the temperate zone better. Subtropical, that's basically the transition between tropical and temperate. It very often has a rainy season, and actually, in the western part of the land masses in the subtropical zone, you actually that's where most of the deserts are. Again, the larger weather systems move west to east generally, and weather models handle that pretty well as well. Tropical. Here's where things get a little bit interesting, which is why I started at this level. The tropical region, it's warm to hot year round. Weather systems move east to west generally, so they move in the opposite direction. And weather models struggle in the tropics, and the reason for that is that there's no real strong winds at pretty much all levels of the atmosphere. The other zones, the winds get pretty strong, and so the the models can handle that. But when there's only subtle differences between things, like there is in the tropical region, it gets a lot harder to have weather models work. So atmospheric scales, basically the global scale, that's, like when you hear about El Nino and you hear about the NAO, well, actually a lot of people probably have not heard about the NAO, but that's the North Atlantic Oscillation. And it's basically a semi-permanent region in the North Atlantic Ocean that basically, as it moves around a little bit, it affects the global weather patterns. So that's another one. The polar jet stream, which actually, when you see folks on TV tell you about the jet stream, the polar jet stream is one of those that's basically a global scale, because it's pretty much always there. It's not always not always strong, and it does move around, and you get the polar vortex stuff and all that. But basically, that's still considered a global scale level feature. So you go down a little bit from that, and that's the synoptic scale. Okay. Larger scale weather systems like highs and lows at the surface and fronts are basically synoptic scale things. The synoptic scale is most dynamic in the temperate zones and also in the subtropical zones. And again, a synoptic scale is handled well by most forecast models. Then you get down to the mesoscale. Mesoscale is sort of one of my favorites because it's the thunderstorms, and you get some really, really impressive looking things happening with a lot of thunderstorms. So I like the mesoscale. Mesoscale level. It's harder to forecast because it's much shorter term features, things that are a lot harder to detect, and everything is a smaller size because you're looking at thunderstorms and general showers and that kind of stuff. So, but the mesoscale is where a lot of people think the most interesting weather happens, but that's debatable. But anyway. And then microscale, which goes down even smaller, and things at the microscale don't last very long. They might last up to an hour, maybe a little bit longer, but they don't really tend to last much longer than that. So the kind of things like tornadoes and microbursts are these small scale features that basically are even more difficult to forecast than things at the mesoscale. So. I did want to mention the jet stream. Everybody's probably seen it on TV. They'll say, oh, the jet stream is doing this and doing that. And like I said earlier, that's really the polar jet stream. There is another jet stream called subtropical jet. Okay. But usually that doesn't get this far north. Sometimes it does, but usually it doesn't. So when they show you the jet stream, they're showing you the polar jet. And they're going to usually show you something like this, okay? The reality is, here's what the jet stream actually tends to look like, okay? It is not just one steady line that's going across the country and waving around and everything. There are places where it's really strong. There's places where it's weak. There's places where it's sort of hard to see the connection. This chart here that I'm showing is basically the color coding is the wind speed. Okay, so you can see that there's actually a jet that goes down into down towards Texas. Let's see, what else do we got there? New Mexico. Basically and that's pretty strong. The red, I think that's a red color, but basically that, you're up in some really strong 500 millibar winds there, which are associated with the jet stream. Okay, but then as that goes up towards like Nebraska and everything, the winds die down a good bit. Okay, and you get up to North Dakota, and you got really, really light winds. Okay, but then as you see, it gets up into Canada and it picks up again. Okay, and that's really sort of what happens with the jet stream. And the reason for that is you can see where the reds are. you can see that the wind, those little lines there are actually basically how strong the pressure is. They're actually called iso heights, which is the altitude, how high 500 millibars is, but basically it's equivalent to the pressure. So where the pressure lines are real close, the winds are going to pick up. And when the pressure lines spread out, the winds slow down. You'll see that in the wintertime, you'll see us get really strong winds, and that's because the pressure is gradient is high. So anyway, I know that probably may not have helped a lot of people, but the trick is that the jet stream changes speed and spreads out and everything else. It's not just that one single line that you'll typically see on TV.
Lou,
Okay.
what kind of altitude are we talking about for typically?
Okay, well, 500 millibar, I'm trying to remember. I think 500 millibar might be like about 10,000 feet.
Okay.
Yeah. Okay, but I mean, the jet stream actually is not just at that level. It's actually above and below that. But I just chose 500 millibar because that's sort of a mid-level kind of thing. Because that's I could have shown you the 300 millibar and 200 millibar and all those, which are up even higher, and you still would you see something very similar here. Okay, but at any rate, so that's really what the jet stream is. It's not this big contiguous stream going around. It actually does speed up and slow down and everything else. Okay, so why is that important? Well, it's important because if we get a storm around here, how does the storm form? Okay, and the way a storm forms is sort of listed here, but the key thing, and again, that's that same chart again, but I zoomed in a little bit and pointed to where the winds are slowing down because the pressure gradient is lessening basically. And what happens when that happens is that tends to pull air up from the surface. Okay, because the air is spreading out, and when the air is spreading out, the atmosphere tries to fill it in. Okay, so you got this stuff. This upper atmosphere is sort of pulling up from the surface, and if that area crosses a stationary front, you guys all know what fronts are, I hope. Fronts are the boundaries between two air masses. So if you have a front that's not really moving very fast, and this area where the winds are dying down, so the air wants to move up, crosses over that front, and if things happen just right, you basically get a kink in the front, okay, and that front develops into a low pressure system and then develops into a full blown storm. So, I mean that's how you get a storm. And again, the models actually usually handle that pretty well. They usually can see a storm coming pretty far ahead of when it actually even forms sometimes, because the models handle this pretty well. So again, I sort of described that in words, but here it is in pictures. Up here at the top, you see the stages of development. Basically, you have this stationary front. Okay, so you can see stationary front. We're in the northern hemisphere here, so those arrows that are basically going to the west are the cold front, or the cold air. Sorry, along the stationary front, and the stuff moving to the east is the warm air. So you basically have a stationary front. There's not a whole lot happening on it. What happens is that upper air sort of moves over that front, and it basically pulls on it a little bit, and the low pressure system develops in a wave on that front. Okay, so that front turns into a warm front, a cold front, as you can see. If you guys don't know, the warm front has the red circles on it, and the cold front has the blue triangles. And hopefully I got those colors right. But basically, the warm front is warmer air is moving in the direction of those circles. So in this case here, warmer air is basically moving to the north. Okay, and then the cold front, the blue triangles show you that the cold air is moving to the south. Okay, and as that wave develops, it's basically a weak low pressure system, but it gets stronger and basically gets really strong. And then what happens is it loses its upper level support and starts to die down. I mean, that's really sort of the simplest way to do it. So that's how storms develop, and that's how they how they progress through their life cycle. What's pretty interesting, at least here, if you're like local to, and I think everybody is local to this area, one of the reasons we get some intense nor'easters is because you have a lot of times in the wintertime, you have a stationary front that's right along the coast. So you get an upper level trough move across with this divergence at the upper levels, and it kicks off a storm right along the coastal stationary front, and then it just intensifies and goes nuts. So that's why you get the nor'easters around. I don't know if anybody obviously, if anybody has any questions, just try and interrupt me. Hopefully I'll hear you. But so that's really, to me, that's sort of the key thing about forecasting the weather is how do you know where the storms are going to be, and how do you forecast them? And again, I said the models actually handle that pretty well. So one of the things that you do when you're doing this is you look at the models, but the other thing that you want to see is how close the weather that is happening compares to what the models thought it was going to be. Okay. And you do that with a bunch of different instruments, including some weather satellites. And hopefully everybody's familiar with the GOES satellites, the geostationary satellites. You've got the GOES East and GOES West. Most of what we want to see you can see best on GOES East, but GOES West also has a pretty good view of this area. That link there that I have is sort of my favorite place to go to get a look at these satellite pictures. Okay. weather.cod.edu/satrad, and they actually have some very nice presentation of the satellite stuff. There are also other satellites which are basically low Earth orbit LEO satellites, but they're polar orbiting. So they circle the Earth from pole to pole, and basically the Earth moves under it. So they're getting swaths of the Earth as the Earth is moving around. Those are actually used for a lot of things, and they're actually sort of pretty important for tropical things, but they also are used for other things as well. So I'm not going to go into too much detail about those at this point, but again, that cod.edu link that I showed, this is like one of the things you can get off of it. And hopefully everybody can see this well enough. The GOES satellites recently were upgraded to produce a lot more output. Okay, and one of the things that they have all these channels. So if you look there on the left, it shows all the bands that you have. So you have visible blue, visible red, whole bunch of infrareds. There's some water vapor loops, and a whole bunch of other stuff. And those are all pretty cool. It's more than what you used to get from the GOES satellites when they put up the new satellites, but it's still, stuff that you have to have experience with reading to figure it out. However, if you look down a little bit further, you see the RGB color products. And those are actually sort of pretty cool because it actually will combine these different bands to produce some interesting information. Okay. One of my favorites, if you look down there, you see NT microphysics. I don't know if everybody sees that, but that's nighttime microphysics. And one of the things that one is really good for is seeing fog at night. So I really sort of like that one. But generally, that's what you can see. And you can actually like zoom in on certain parts of the country, and you can also zoom out and look at the Atlantic Ocean and all sorts of stuff. So you can do with it. Here's what I mentioned about the nighttime microphysics. Both of these shots were taken at the same time, and one of them is just your standard run-of-the-mill infrared, okay, on the left. And if you look at that infrared on the left, you don't really see much. There's really not a whole lot to see there. If you look at it on the right, that color is basically low-lying clouds and also some fog. So it really makes it stand out. As with all satellite products, you do get things that might block it. So like if you had a thunderstorm coming through and there was also some fog, you might not see the fog because the thunderstorm is what you're going to see. So, not perfect, but none of this stuff is perfect. Okay. Radar. Hopefully everybody's familiar with the radars that you can see on the internet. You see them on TV a little bit. You see them all sorts of places. There's lots of different kinds of radar, as probably most of you are aware. Most of the ones that are used by the Weather Service are one of two types. One of them is called NEXRAD. It's also referred to as WSR 88D, basically because it was started to roll out in 1988. So that's where they came out with it. And the reason it has the D on it is because it's Doppler. Okay, the WSR 70, can't remember. The original one was in the 70s and it was not Doppler. So anyway, there are also some terminal Doppler radars. Okay, they're mostly FAA radars near airports. So there is a TPHL, which is near Philadelphia, and there's TNWR up by Newark and all those. So there's a bunch of those around too. Those are lower power. They're a different radar band, but I can't remember which band they are. But they, so they don't go out as far, and they're not, they're not dual pole. Okay. If you look at the last bullet there, I talk about dual polarity units. The NEXRAD radars recently were upgraded so that they now produce both a vertically polarized and a horizontally polarized pulse. And they get some really sort of neat products out of that you can't do with a single polarity. So, so that's sort of a cool thing. There are a bunch of non-NWS sites out there. And I actually wish we had more around here because there are some holes, especially around like Berks County and Lebanon County and a couple of places out there and a couple other places. And it would be nice to have things to fill in, but we don't. So as much as I've campaigned for it, nothing has happened, which I guess I'm not surprised. But anyway, if we could get more radars here, that would be great. But for now, we got NEXRAD and terminal Dopplers pretty much. So I mentioned that the dual polarity stuff came out a little while ago. This is from Springfield, and I grabbed Springfield, Missouri, because there was actually rain out there today, so you could actually see something. But if you look at the upper left, that's typically what you see on most radars. You see, just plain radar echoes. Sends out the beam and basically gets the return back, and it plots what it thinks it saw. The upper right is actually a velocity scan. Since it's a Doppler radar, it's a velocity scan. A lot of things you can do with velocity. I'm not going to go into great details and all the things that it'll tell you, but you can actually see circulations, and that'll help you find tornadoes on the radar and that kind of stuff. The lower left is that's something called the differential reflectivity, and that's one of those dual polarity things that I was talking about. And it's one of the things that helps you figure out if there's hail falling. A little bit complicated in how it's all done, but basically, because of the dual polarity, you have you can really pretty well figure out if there's big hail falling. Okay, which is, you know, the kind of hail that you really want to know about. And then the lower right is what's called the correlation coefficient. And that one's actually very useful for a lot of stuff. One of the key things it's useful for is knowing if you're actually looking at precipitation, or if you're looking at birds, or if you're looking at bugs, or whatever you're looking at. Okay, and the reason is the correlation coefficient, the closer it is to 100, the more it is indicative of precipitation. And if it gets down below 80, then you're probably not looking at precipitation. And sort of in between, there's some, you know, some variation on that. Where this becomes really, really useful is... Hello? Okay. Where this becomes really, really useful is if there's a tornado coming through and the tornado's hitting something, and whatever it's hitting is getting drawn up into the tornado, you will see sort of a, you know, an area of below 80, below 70 correlation coefficient right there where the rotation is. You'll see the rotation in the velocity scan. You'll see that there's a, you know, this area where it's not precip, right there where that rotation is. And there's a couple other things you look at, but if that all happens, then they will actually confirm a tornado based on that. Okay. Prior to dual polarity, you could not confirm a tornado in most cases with radar. So now you can, which is, you know, very useful. So like last year when, I mean, we had tornado outbreaks a couple of times last year. They confirmed a couple of the tornadoes right away because they saw, it's called a debris signature, or a TDS, debris signature. And they saw that on radar and they said, yep, we'll confirm it. So dual pol is actually pretty darn cool. Another tool, which is really important and sort of radio related, is something called radiosondes. And actually they usually are operated as ray wind sondes. Okay. Yeah, I did put that in there. Which is a radiosonde that you're also tracking, you know, tracking distance and everything else. You know, how fast it's moving and all that stuff. And that gives you a good look at both the conditions close to the ground and also way up in the atmosphere. These things, they're launched with balloons. I'm sure you've seen weather balloons somewhere. They're launched with a weather balloon, and they just keep going up and up until the balloon bursts, and then they'll come back down. They're actually pretty low cost transmitters is what they are, and they have a couple. You know, they have a temperature, humidity, what else? Yeah, and then basically they're tracked with the wind speeds, and that gives you, you know, that gives you all the information a pretty good profile of what's happening in the upper atmosphere. Because again, if you remember back to what I talked about how storms form, you need to know what's in the upper atmosphere in order to be able to figure out where your storms are going to form. So one of the ways they do this is they send up the ray wind sondes. The ones that they're using transmit on either 403 megahertz or 1680 megahertz. So, I mean, they have some pretty good receiving stations to be able to receive these things, because when they get caught up into like 50 knot, 80 knot winds, they move pretty far away from where they were launched. So, you know, so they have Earth stations that are listening for these things and you know, and receiving the data. But you know, those are the frequencies. You could try and listen there, but unless you have a really good station, you might not really hear much. And unfortunately, recently there's been a helium shortage, so there's a less balloon launches happening than there used to be. So the look at what the upper atmosphere is now done more with satellites than with balloon launches. They're still happening. You still get the data, but they're also being filled in with what they can see on satellite, which is not as good as what you get from a balloon launch.
How can you have a party without helium?
Yeah. You never invite me to those parties. Oh, no. Anyway,
Is there a reason why those two frequencies were chosen?
I mean, the hardware that they're using basically transmits on those frequencies. So I don't know why they were chosen, but they're the ones that they're using. And I guess, Jeremy, you have some experience with balloon launches, I think, don't you?
Not directly, but the VU Club has launched a couple of balloons.
All right.
Alan, KU2Y was more involved with those.
Yeah. Now, did they, what frequencies did they use? Because, I mean, there are actually a bunch of groups and organizations out there launching balloons, and there's a website, which I can't remember what it is right now.
I have the website. If I don't want to share the screen, but the website is called Amateur Radio High Altitude Ballooning. It's arhab.org.
Okay. Yep. And that, well, and there's the, you know, some of the groups that are putting them up are not really amateur radio groups, but basically there's people who are putting up balloons, and there's websites where you can get some details on what their balloons are seeing. So you can get, you know, you can get an idea of what's going on. I didn't include something called well, soundings. When you put up a sounding balloon, what they do is they take the data and they plot it on a graph, basically. And the way it's plotted on a graph, it's sort of easy to figure out what's going on in the atmosphere. That'll be a topic for another presentation if you know, if you want to talk more about that kind of stuff. But I didn't go into that in too much detail in this presentation. But at any rate, there's what, you know, typically a balloon, that's what you're going to do. You have this little instrument pack. She's got that in her lower hand, and then she's got the balloon, and you fill up the balloon and you let it go. Where she is, it doesn't look like the winds are all that strong at the surface. And I saw a video a while ago of a guy putting up a balloon launch in a hurricane, and that was actually pretty interesting. So, you know, so they're not always this easy to put up. So, but anyway, in addition to all this other stuff that you can get, there's actually surface observations. A lot of the surface observations come from something called an ASOS, and there's also some things out there called AWOS, which are older things, but they're basically instrument clusters. National Weather Service, the FAA, most of them are at airports, so that's why the FAA is involved. Most of them are totally automated, but some of them are actually sort of, you have people filling in with them. But anyway, in addition to what you would expect to see at a weather station, they also have specialized instruments to try and detect fog and what type of precip is falling and all sorts of stuff. So there's a lot of stuff with one of these weather stations. The other, I don't know if the people here are familiar with CWOP, Citizens Weather Observer Program, I think is what that stands for. But anyone who is a amateur radio guy who has a weather station that they'd like to share with the Weather Service, you can sign up for CWOP. You don't have to be amateur radio, but basically amateur radio is sort of easy because then you just send it out on APRS and, you know, and the Weather Service will pick it up. If you're not an amateur radio guy, then there's another way to get your data to them, but the CWOP via APRS is a good way to do it. And I did not put the link in here, and I apologize, but I can send the link out to people at some point about, you know, how to sign up for CWOP if you want to. And you don't have to use APRS, but that's one of the ways you can do it. And, you know, you can, if you're already doing APRS weather, then you can just sort of sign up for CWAP and not change anything you're doing. Ultimately, the surface data is viewable at NOAA.gov by that URL there. It's MADIS data and MADIS surface. And basically it'll give you more information than you ever really wanted to know about what kind of surface data they collect. And this MADIS thing that they have, they collect all the surface data, and they also collect the upper air data as well. And then they quality check it, decide whether, you know, whether it's a good quality report. You know, so like if it's summertime in Florida and somebody reports a 0 degree Fahrenheit reading, they're going to say that that's a pretty poor quality report. You know, so they do that kind of checking on it. But once even the poor quality ones are going to be on that website, so you can look at them, but they're not used in. This data is some of the stuff that gets fed to weather models to initialize the weather model. There you go. There's what an ASOS looks like. As you can see, there's in the center there's like a 30-foot pole, and that's where because the standard for recording wind speed and direction is at 10 meters. Okay, and then, you know, everything else is sort of recorded closer to the ground. But like I said, there's all sorts of specialized instruments for all sorts of specific things that they're looking for there. So some of the more advanced ones actually have things that try and figure out how much snow is on the ground and all sorts of stuff like that too. So there's some pretty sophisticated stuff going on there. Okay. Probably anybody who's watched weather on TV is familiar with forecast models. Okay. There are numerous models. I listed a few of them here. A lot of times on TV, they call them something different, like the GFS, they like to call the American model, and the ECMWF, which just sort of rolls off the tongue, but maybe not. But that they usually call the Euro model. Okay. The NAM is the North American model. It really is basically just the United States, you know, and a little bit into Mexico and a little bit into Canada. So it's only good for forecasting things once they get close to the US. NAM Nest is similar, except it's got a finer grid and it runs more often. And so you can start trying to forecast thunderstorms with the NAM Nest model. Okay. With the NAM model and the others, the GFS and the Euro, it's real hard to forecast. You know, you can say this area is going to get thunderstorms, but to figure out where the thunderstorms are going to be to more granularity, you can't do that with the NAM, GFS, or Euro. Okay. The NAM Nest and the HRRR, you can actually do that. They actually do go down to that granularity, and they actually try and forecast where the thunderstorms are going to be. They're not great at it, but they can do really well. You know, if the model initializes well and everything else, so that stuff in MADIS is in good shape. They do a real good job of actually telling you where the thunderstorms are going to be. So all models do have strengths and weaknesses, and all models basically have limitations. You know, if it doesn't initialize properly, then you basically got garbage in, so you're going to get garbage out, and that happens occasionally. Extrapolation, propagation. So basically, most of these models are actually doing grids. So like the NAM Nest is a 3-kilometer grid. Okay, so to figure out things in between, you know, in that 3-kilometer grid, there's some extrapolation that goes on as they connect all these grid points together. And that extrapolation, if it misses something, then it's going to keep missing it basically. So, so that causes problems with it. And basically, these are big mathematical engines, and sometimes you get some rounding error that happens. And so the further away from when the model was run that you go, the worse the output is going to be, because it's just, the little rounding errors like start piling on, and you don't get really good output. One of the things if you spend a lot of time on the internet and look at weather stuff, you'll see these people saying the 384-hour GFS is saying that we're going to get slammed with a nor'easter. Well, 384 hours is 2 weeks out. There is so much error, at over 2 weeks out, that it's unreliable. It really is. The Euro doesn't go quite out that far, so it doesn't get that outlandish. But if it went out that far, it probably would get that outlandish. So, those are the things to keep in mind. The models sometimes do really well. Further away from when they're run, they do deteriorate. So, okay. So just sort of to wrap up the mid-latitude stuff, I know I didn't go into too much detail about it, but basically overall, the dense data network, because you got all these people feeding surface data into it, and it's somewhere around 90 spots around the 48 states where they send up balloons. So that's not as dense as you would like, but it still does a pretty good job of figuring out what the upper atmosphere looks like. So the weather models actually, as long as they initialize correctly, actually do a pretty good job, for a couple of days out, maybe up to a week out. But, they actually do a pretty good job. Tropical forecasting is a different animal, and I'm going to talk about that in a little bit. But even with all this, because there's some things that can happen, a lot of times you'll hear a deterministic forecast. You'll say, you'll hear 50% chance of rain. Well, no, sorry, let me back up here. A deterministic forecast is basically saying, we know for certain it's going to be 86 at Philadelphia at the airport. And that's what I'm forecasting, and that's what I'm saying we're going to see. Okay. It's rare for those to absolutely verify. They're usually pretty close, but they might be a degree or two off and that kind of stuff. So deterministic forecasts, although that's what everybody wants, those are harder to do. Okay, it's harder to say it's going to be 86. So many forecasts, especially things like precipitation and that kind of stuff, they're done probabilistically. And basically, so you're saying, okay, 50% chance of rain at Philadelphia, because it may or may not rain there, or you're just not 100% sure. So you do more of a probabilistic forecast. That's important again because of tropical zone. In the tropical zone, you get a lot more probabilistic stuff happening. Okay, and again, the tropical zone, like I said earlier, it's warm to hot year round. Weather systems move a lot slower. There are very few actual fronts in the tropics. Remember for the mid-latitude stuff, what I talked about was you got this upper air crossing a stationary front. In the tropics, you probably are not going to find a stationary front. If you are, it's probably lost and it's probably going to dissipate pretty quickly. But sort of generally, you don't find a lot of fronts in the tropics. About the only thing that sort of approaches a front is something called the ITCZ, Intertropical Convergence Zone. Some people pronounce that itch, although I'm not quite sure why it's pronounced itch. But anyway, it's a region pretty close to the equator where the northern and southern trade winds meet. It doesn't stay right at the equator. It actually moves north and moves south. It moves north in the northern hemisphere summer, moves south in the southern hemisphere summer. It actually waves around a good bit too, One of the reasons it waves around is because when it crosses, it crosses a landmass like Africa, it experiences friction. And so basically it starts to really sort of, change direction and everything over land masses. But as you get, as you're over the ocean, it really is sort of pretty sort of, west to east. But what happens is, because you have this convergence zone, you get some air moving upward. Okay. And air moving upward, if you remember from Skywarn, upward air is basically going to condense. Okay. And it's going to, basically form rain, or might form thunderstorms. And in fact, with the ITCZ, it does form thunderstorms. And so right where the ITCZ is, if you look at it on satellite, you'll see this string of thunderstorms moving west to east, generally across the land masses in the ocean. So, and the trick is, again, because, what you're looking for tropical weather is tropical cyclones. So like tropical depression, tropical storm, hurricanes. In other basins, they call them cyclones. They call them, I forget what the one is in Japan. But they have all these different names. What's that?
Typhoons.
Typhoons. That was the word I was trying to think of. Yeah. So basically, but they're all basically tropical cyclones, and there's no difference between them other than the fact that the typhoons actually can get really, really strong. If the ocean is really, really warm, they can get really, really strong, and it happens a lot. So, but at any rate, most of the Atlantic Basin tropical cyclones that happen, they start as waves along the ITCZ. So the ITCZ is a very important feature. Okay. So what do you need to get a tropical cyclone? There's a whole list of things here. One of the things is you have to have really warm sea surface temperatures. Okay, so 80 degrees or higher is usually what you need. There are pretty much always in weather, there are exceptions to everything. And of course, there are exceptions. There are some tropical cyclones that might form in a little bit cooler water, but typically you're going to need like 80 degrees Fahrenheit or warmer. And it also needs to be a deep layer of warm temperatures. Okay. The more shallow it is, the less likely it is for a long-lived tropical cyclone to propagate, because it's it will eventually cool. The ocean will pretty quickly cool down because it's not a deep layer, and then it'll start to eat into the tropical cyclone. Not too far away from the equator, but basically, it's somewhere near the equator. Again, it's going to form usually on the ITCZ. So that sort of makes sense. Pre-existing disturbance, well, the ITCZ has all these thunderstorms right along it. Okay. So that you're looking at the ITCZ. Okay, but you have a disturbance, and if they get a little bit more robust, then yeah, that'll really help to form a tropical cyclone. You don't want the wind shear to be too strong in the upper atmosphere. Okay, from about 5,000 up to 38,000 feet. Less than 20 knots. I don't know if you remember that chart I had a while ago from the 500 millibar over the United States, but you had like some 80-knot winds that were there. So you're going to have really strong wind shear over the, over the U.S. and in the mid-levels, mid-latitudes. Okay, and that's good for storms to develop. In the case of tropical weather, if you had 80 knots of shear going on, you wouldn't have anything happen. So it's totally different animal. And it's, it gets a little bit more interesting to try and forecast it. You have to realize that when you're forecasting it. Okay. The middle troposphere, relatively moist. Okay. So, a lot of times you get these dry layers. I didn't include it in my pictures. I probably should have. You get this thing called the SAL, which is the Saharan air layer. Okay. And what happens is you get this really, really hot, dry air coming off of the Sahara into the Atlantic Ocean. And if that layer is, close enough to where the storm is trying to form, it's just going to kill it because it's too dry. Okay. So that's another thing that you need to look at when you're trying to figure out if these things are going to happen. And then a troposphere that is neutrally stable or unstable. And again, instability is sort of a hard thing to explain. And I usually explain it like hot air rises is sort of what you've heard like for years. Okay. Hot air rises if the air above it is cooler. Okay. And so that's instability. Okay. Hot air that's rising is actually going to cool, but it's got to cool slow enough so that the air above it is still colder, and then it will keep rising. So that's what it means by unstable or neutrally stable. Okay. It was a little more technical than I wanted to get in this presentation, but it's sort of important to basically see that it takes a lot more to get a tropical cyclone going. And to get it to intensify and everything else. It's a really, really complex process that happens. Okay. So once you see these things starting to develop, how do you figure out whether it's a tropical storm, whether it's, how fast it's spinning, all that stuff? Well, out there where they usually form, especially if they form closer to Africa, you don't have a lot of data. You don't have this dense data network that we have here in the US. Okay. So you have the satellites, the satellites provide more information than they used to. I mean, back when they were initially trying to forecast hurricanes, they didn't have any satellites, so now we've got a lot of satellites up there. So they really help, but they're still sort of, not as much detail as you would like from the satellites. Okay. So back in the olden days, they came up with these Dvorak numbers. Okay. And they assign a number based on what it looks like on satellite. Okay. The higher the number, the more intense the cyclone. And then there's another thing called Hebert boxes. And these are actually two regions in/near the Caribbean. They usually indicate if a strong cyclone that goes through this box and heads towards Florida, it's probably going to hit Florida. I mean, that's really what these boxes are used for. And there's a bunch of other things that used to be used. They some of them were just rules of thumb and didn't always work, but these two actually work pretty well. So here's the Dvorak numbers. I always want to say Dvorak because that was a musician, but I don't know what the right pronunciation is. But at any rate, you can see that these numbers go from, well, T1.5 is the lowest on this chart up to T8. T8 is basically going to be your category 5. Strong category 5 hurricane. T1.5 is just the disturbance, basically. T2 is tropical depression strength is sort of a T2. And then T2.5 is where you actually get into being a tropical storm. And then you go up from there. So even at T5, which I forget what category that is. Even at T5, you can have an eye. Okay. Sort of below that, you don't really see much of an eye. Sometimes you do. So these are not perfect, and but basically they really, that's what they used to figure out how strong a hurricane was when they saw it on satellite. So, and they still use it to a certain extent, although there's some more tools that actually make it a little bit less useful than it used to be. And there's a bear boxes, okay? And you got the one box out there by the, what is that? Is that the Leeward Islands? I think that's the Leeward Islands, right? And earlier in the season, if a strong system went through that box number one, the chances of it hitting South Florida were pretty high. Okay. And maintaining most of its strength. Later in the season, a bear box number 2 is used. And basically, if something goes through that box and turns north towards Florida, it's probably going to hit South Florida. Okay. And I'll actually have a couple of pictures later on to show that that's what Hurricane Ian did. Hurricane Ian went right up there through that box and then just went straight north towards Florida. So, okay. So how do you figure out what these tropical cyclones look like, how strong they are, what they're doing? There's all sorts of things that you want to know about these things when they're out there in the ocean so you can figure out what they're doing. Okay. When they get closer to the United States, the hurricane hunter flights go out. And there's hurricane hunter flights from, the Air Force Reserves. There's hurricane hunter flights from NOAA themselves. They have all sorts of different special purpose hurricane hunters. Some of them fly really high, so they're getting the readings from very high in the storm. Some of them actually will go way down in the storm and actually skim across the ocean, so they do all sorts of things. But generally, the ones that are flying through the storms, they're dropping dropsondes, which are again these instrument packs similar to what are in the Raywind sondes, and they're dropping them inside the hurricane to get readings of what's going on in the hurricane. They still are flying cross sections. Okay, so they're not flying every part of that hurricane. They're flying across, and then they fly across at a different angle, and so they get some good readings, but they do occasionally miss stuff because they just don't hit the right part of the storm at the right time. So, but they're actually very good tools, and when they find the strongest part of the storm, they get it measured and they get the information down. There are websites and that you can actually look at their data. Their data is pretty dry, but if you want to see what they're sending back, you can look at it there. Another one that is actually very useful is something called a scatterometer. Okay. Scatterometer is a radar unit that's actually up in the sky, basically. Okay. They generally are mounted to low Earth orbit satellites. Okay, because they're doing they're doing radar. They're doing radar that's not going to penetrate too far in. They want to get relatively close. So they have a radar unit on these satellites, and the radar unit actually beams down. These LEO satellites are polar Earth orbits. So basically, they're getting swaths of data as the Earth is spinning under them and they're orbiting around and everything. So they end up producing some things that I'll show you a picture of it a little bit later. But what they are measuring with these radar units is how rough the seas are. Okay. And the rougher the seas are, the faster the winds are, basically is the connection that they make. They can mount these things on aircraft and, they get them even closer, but basically these are scatterometers. They're a very useful tool. There's the other polar orbiting satellites, the POSE satellites, and they have lots of microwave instruments for all sorts of things. They can actually I lost the picture that I was going to show for this, but there's a posed satellite that actually measures the temperature at various levels of the atmosphere. And it does that by basically, measuring different wavelengths. Different wavelengths are generally sort of being produced by different parts of the hurricane, okay, or the storm. And basically, one of the things you want to see in a tropical storm, which I didn't mention, but these things are warm core, okay, which may or may not be significant to you guys, but a typical storm over the mid latitudes is cold core. Okay, so the air that's in that storm and being pushed up is colder than the core of the storm is actually pretty cold. Okay, in the case of a tropical system, what happens is you get all this air moving out, and you get some air subsiding in the middle of the storm, which is why you get the eye. Okay, but that subsiding air is actually pretty warm, and it actually warms up as it subsides. So there are the posed satellites. There are some out there that have these. I think it's like 85 gigahertz or something that some of the frequencies it's using. So the pretty high frequency things, but they're still still sort of and again, the higher the frequency, the closer you're going to want the orbit to be. Just because. You can actually, with these instruments, figure out if what you're looking at is a cold core or a warm core. Okay, and if it's a warm core, then you're looking at a tropical system. Because sometimes when these things first develop, it's a little bit hard to figure out whether they're actually tropical or subtropical or mid-latitude or extratropical. There's all these different kinds of storms. But when they're the tropical storm, that's when they are a big concern. Some of the other storms are a big concern too, but these are definitely a big concern. There's the GOES satellites. You can see a lot with the newer GOES satellites that you didn't used to be able to see. And a key thing, because if you remember, I mentioned earlier that the sea surface temperatures, you want to be 80 degrees or higher. Okay. So you got to analyze the sea surface temperatures, and they get they get the sea surface temperatures from things like buoys, from ship reports, from a little bit from these polar orbiting things, but they sort of mash that all together and come up with what how warm the sea surface is. So I mentioned the scatterometer. That's what you would typically see from a scatterometer. Okay, it's basically the Earth is spinning underneath it. It's doing a polar orbit, and so it's doing these swaths as all that's happening. So that's a pretty incomplete picture. The good news is there's a bunch of these up there. Okay, so between all of them, they tend to get a pretty good picture, but they're all in different data sets. So one of the tools which I really like is something called Mimic. Okay, and this Mimic tool actually takes all that information and munges it together, merges it, everything else, and actually puts this kind of animation together of what the storm is doing. Okay, and it's showing you look at the beginning there, you can see the eye and the eye wall and everything else that's going on, and you can see as it gets into land, the eye wall dissipates, which is typical. Okay. So at any rate, the brightness temperature is basically related to the actual temperature of what it's what it's seeing. So the eye wall is pretty warm because it's more part of that warm core. So that's why when you see that eye wall first, while it's still in the Gulf of Mexico, it's actually pretty warm, and then it cools down. So, and one of the things, and this one actually is from today, but this is what you would one of the, I like the colorized air mask because it works day and night. You know, and I'm also colorblind, so the colors don't bother me. I don't know if they bother anybody else, but they don't bother me. But at any rate, what you can see there is like, I don't know, can you guys see my cursor? Okay, so you see sort of here's the ITCZ sort of going along here. You actually do have what's probably left of a front that is crossing way down deep into the tropics. And like I said, that's pretty unusual. Usually they dissipate before that, but but you get the ITCZ and it's always going to have thunderstorms and all sorts of stuff going on along it. And when you get the waves develop and move off of the ITCZ, that's where you tend to get these tropical systems. Sometimes they stay right along the ITCZ, but usually they move off. So that this will give you a good look. A lot of the other products, they work at day or they work at night, but they don't work both. So so I like this one because it works day in. But I don't know if you guys looked at the NHC website today, but the NHC website talked about a couple of areas up here that they're thinking might develop into something. Pretty low chance. And that's the one thing with tropical systems. Almost everything is probabilistic. Almost everything is probabilistic. Okay, so they're saying like what? There's 3 areas. One of them, I think they're saying 10%, 130. There's one that at one point they had up to 70%, but now I think it's back down to 30. So the chances of these things actually developing into a tropical cyclone are pretty slim. The trick is once they develop into a tropical cyclone, then there's a bunch of forecast models that kick in when that happens. Because again, the forecast models don't handle this really well. So you get a lot of forecast models that try and handle is basically what happens. I don't know if you've ever seen it on TV. You see those spaghetti plots, and that's all these forecast models that normally don't run. But as soon as they actually decide that this thing has a really good chance of being a tropical system, then these forecast models start running, and you see the spaghetti plots. Okay, but you don't normally see them. So at any rate, they're not at a level where they're gonna fire up the spaghetti plots yet. They have to call it, and you may have heard the term an invest. Once they call it an invest, that's when those things fire up. So anyway, so probably everybody on this call is familiar with the National Hurricane Center. National Hurricane Center is only one of the tropical cyclone centers around the world. There's the Central Pacific Hurricane Center, which is also part of the US. But then you got Japan, India, which is the North, and France. India has the North Indian Ocean and France has the South Indian Ocean, which is interesting. But then you have a couple of guys that do South Pacific or Southwest Pacific. Generally, you don't get a whole lot of tropical systems in the Southern Pacific. So I'm not sure how busy those guys are, but they're there and they're ready in case they get something. So what kinds of things does the National Hurricane Center produce? They produce lots of probabilities, lots of probabilistic forecasts. Probabilities of tropical storm force winds, hurricane force winds, surge forecasts, landfall location. Landfall location, that's what everybody's familiar with the cone, okay, is where this thing is going to, where it's going to travel, and then basically landfall is one of the things that's covered there. So anyway, this is all for Ian. I gathered a bunch of data from Ian, and this was what was this, a day and a half before landfall, approximately. In fact, almost. Was it a day and a half? before landfall, and they were basically saying there's a pretty good chance of hurricane force winds hitting a good chunk of the Florida coast. Okay, and I don't know if you remember that one of the things that was that was controversial was where it actually did eventually make landfall, which I think is right around here. The guys didn't think the forecast was bad enough to actually evacuate, and so they didn't evacuate. They ended up getting a direct hit. Okay, so they're saying there's a good chance you're going to get hit hard, and they said, oh, it's not hard enough, so we're not going to do anything. So me, if I saw that and I was on the coast, I'd be getting inland right away. But I know what I'm looking at. A lot of people don't know what they're looking at, and they're waiting for somebody to tell them to do something, which is often a bad idea. Hurricane Ida last year, so many people didn't leave their houses along the Perkiomen Creek because nobody told them to leave. The Weather Service told them it was going to be catastrophic, but they were waiting for somebody to tell them to leave. So, anyway. All right, and here's the famous cone. And Ned's still there, so hopefully you'll see this cone. The cone actually has two different forms, maybe even three, depending on how you think of it. There's the cone with a line, there's the cone without a line, and then there's the cone with or without a line, but also with the wind field that it's starting out with. Okay, and I'm going to show you all of those. But the trick with the cone is that for the date and time that they have there, that's if it's in the cone, there's a 67% chance. They're saying that there's a 67% chance that the center of that storm is going to be somewhere in that cone. 67% chance, which, that's pretty high probability. People are familiar with like standard deviations. That's basically one standard deviation either way, so you look at the bell curve, that kind of stuff. I don't know how many people are really familiar with statistics and that kind of stuff, but basically, that's your one standard deviation either way. They actually build this by, every place that you see that little dot with either an M or an H or an S in it, they actually draw a circle around it to represent that 67%. Okay. And then they smooth it out to make it a cone. Okay. So you can actually see that once you get out to, what is that? That's, I forget how many hours, but this was done at 5 a.m. Tuesday. So by 2 a.m. Friday, so that's 3 days out, basically their cone got really wide there. So that circle that they used to draw it was a really big circle. So the error, the forecast error that they expect once it hits land is higher, which makes sense. Once things hit land, then there's all sorts of stuff that happens with it. It starts to weaken. The wind fields actually get bigger. The rain actually spreads out. All that stuff happens. So they're a lot less sure of where it's going to go once it hits land. So that's why that cone gets really big once it hits land. Okay. I like it without the line. I actually prefer that they would not even have those circles in the middle of the cone, because people still see a line when they do that. And the trick is, don't treat that as a line. There at 2 a.m. Thursday, where it says a major hurricane is going to hit there, that's not what it's saying. 2 a.m. Thursday, a major hurricane is going to hit somewhere between here and here is what it's saying. So, but people don't read that. People see that and they say, okay, it's going to hit Tampa. And there were people out there saying it's going to hit Tampa. So,
But isn't there a 1 out of 3 chance that it'll land outside the cone?
yeah, absolutely.
So, I mean, people who say, "Oh, I'm outside the cone, I don't have to worry." That's still a 1 out of 3 chance. that it
Exactly.
hits somewhere.
Yeah. Yeah. So it's one, yeah. And these are all the things that people with probabilistic forecasts, people don't, a lot of times they don't understand what's going on. It's sort of hard to figure it out. Ned, you have your hand raised?
Yes, and I have left the noisy venue where I was. There. Jeremy just mentioned the 1 of 3 chance being out there. I'm curious, is somebody, is there an analyst in the National Weather Service someplace who actually has a whole bunch of other maps and cones showing like two standard deviations? Are they like out there? They're just like a whole lot wider.
Well, I didn't put it in the presentation, but there is another thing which is just sort of the probable time it's going to reach a certain location, and that one is wider. There's nothing. It's not exactly a cone, and it actually looks like almost like a kid is drawing it. I'll have to dig one up and maybe send it to people. But yeah, and that's that thing is actually, well, even if it's not in the 67%, there's still a chance it's going to hit, here outside this cone, and they show it that way. So, but they don't really push that, and the reality is that this is the thing that most TV stations put on. They put on this, and they usually put it on with the line in it. So they connect the dots, which is a minor thing, but that's still what they do. So people think that's where the center is going to go. And the other thing is, let's see, does this one say it? Yeah. The cone contains the probable path of the storm center, but does not show the size of the storm. Hazardous conditions can occur way outside. Well, I put in the way outside, but they can occur outside of the cone. Okay. Especially if it moves closer to the edge of the cone, the hazardous conditions can occur way outside, because again, you're looking at the center of the storm. So yeah. So, and you'll notice, like, for example, and here's a good clue. If you look down at 5 a.m. Tuesday down there on Cuba, see how narrow the cone is? Okay. See how big the hurricane warning is? Okay. So you got hurricane force winds basically much outside the cone, and that can happen, and it usually does. Okay. So the cone is only a small part of the story, and people, it's hard to get that message across to people, but it really is. And let's see here. Yeah, I actually did a couple of these. So, as it got closer to Florida, you can see, again, you can still see that they have the hurricane warning outside the cone again. Okay, that's a little bit further down the line, but they still have it outside the cone. This is the one I was talking about, which shows you how wide the wind field is, in addition to the cone. So you see this circle here. That's how big the storm is. And that's how big the actual hazardous wind field is for that storm. You see that so it's much wider than that. So if it keeps about the same size, and it actually got a little bit bigger if I remember correctly. So if it keeps about the same size, it's going to be outside the cone, even up there in Florida. So this is a good product. I don't know how often people actually look at this, but it's like, this was a big storm. Not all storms are this big. This one was a big storm. This one was going to do lots of damage in a lot of places. And this is why they, let's see, I didn't include the storm surge, but the storm surge, why they came up with such big numbers for the storm surge. They were saying, foot and a half, 18 feet, in some spots, was because how big the storm was. The storm surge happens because this thing is pushing water, especially, it's spinning counterclockwise, okay? And it's actually pushing water on the right front quadrant. It's pushing it to wherever it's going. And so when it hits land, it's pushing a ton of water in front of it. And that storm surge in front of it and also in it. So that storm surge is going to hit land. And the bigger the storm is, the bigger the storm surge is going to be. One of the things that's true about tropical systems is that I don't know what happened to my other slides, but anyway, I was pretty much done anyway. But the storm system, what was I saying here? Okay, the storm surge is one of the really bad hazards from a tropical system potentially. Okay, and in fact, they rate the tropical systems based on the wind speed, but more things happen because of water. And when I say water, I mean, the storm surge, the heavy rains, all the stuff that happens in hurricanes. More damage is done by those factors than by the wind, except maybe in like a high-end Category 5 storm. Then yeah, the wind's going to start pulling apart buildings and stuff. But for the weaker storms, you're still going to get devastating effects because of the storm surge and because of the heavy rains. So anyway, I think I'm pretty much done here. I thought I had a final wrap-up slide, which I lost apparently. So sorry about that, but hopefully this helped. And I know I didn't go into too much detail as far as actually forecasting, but that's because that's like that's a couple of semesters course. It's not something I could talk about just tonight. So Ned, did you raise your hand?
No, that's applause. Thank you.
Oh, thank you. So did that help? Did that answer your question, Ned, about the cone and everything?
Yes, though I will tell you that next time I see you, or we're talking on 835 or something, I will be asking you about the difference between my brother in Orlando and maybe watching wind speeds versus my nephew, his son in Tampa, and watching the storm surge. But we'll save that for another time.
Okay. All right. Anyone have any questions?
Great job. Great job.
Oh, thank you, Dennis.
Do these prediction curves come with a black magic marker too?
That's an extra cost. Said money too. I'm sorry.
That's where you put the 2 sigma and the 3 sigma. Yeah.
Mm-hmm. Yep.
It's a good point about the storm surge because people focus on the wind speed. And I know that from Hurricane Sandy a couple of years back, the wind speeds were not that big, but the surge was just enormous. So New York got hit very badly, and the Jersey Shore.
Mm-hmm.
The places were just underwater for days.
Yeah, and that's, Sandy was actually an extratropical storm, so it was getting bigger, because when they transition to an extratropical storm, they tend to expand. Okay, so that's what was happening with Sandy. It was getting bigger. It was actually starting to develop cold fronts and warm fronts and the whole thing. Again, I said it earlier, and it is sort of a key difference. Hurricanes generally do not have any kind of front with them. They are basically just this big spinning monster. The storms that we get up here that are not tropical in nature, you got cold fronts, you got warm fronts, you got cold air pulling in from above, you got warm air pulling in from below, and that was going to be a lot more complicated than I wanted to get into tonight. So That can be for another presentation at some point if people really want to talk about that. But yeah, I sort of wanted to get to the tropical stuff because I knew Ned was interested in that. So hopefully this helped. I could talk for days about this stuff, as you probably know, which is why I was disappointed when Fox 29 only gave me 60 seconds. So that was disappointing.
Lou?
Yeah.
Steve, K3FZT, two quick comments. I lived in Brooklyn in 2012 at the time of Superstorm Sandy. And the thing I found very interesting at that point was that the Stony Brook folks Weather Center was quite accurate about the storm surge and quite different from all of the other reporting at that time. And turned out to be quite right about all of the problems that Manhattan faced. Moving on, I have a weather station in my backyard that I am, thanks for pointing out about CWOP and all the rest of that. Do you have a weather station that you contribute to CWOP?
I do have one, and for a while it was contributing, but then I was running it on a Raspberry Pi, and that sort of is not up and functioning the way I need it to. So someday I'll get it back on the CWOP, but right now it's not on there.
Okay, I was just asking because I'm thinking about it might be fun to do that with my station. So I might reach out if I move in that direction. Thanks very much.
Yeah, I'd be glad to help.
Thanks very much. Very nice presentation. Learned a lot.
Good. That was my goal. Anybody else?
Other questions? Now, what about the smoke from the wildfires? Is that affecting forecasts?
It does. And there are actually, I think the HRRR model, HRRR model, actually does have one of its fields that it produces is trying to track the smoke and forecast where the smoke's going to go. So that is a thing that they will try and forecast. But yes, if you're under the big cloud of wildfire smoke, it's going to affect your temperature. It's going to affect a couple of other things. So it's one of the interesting things. I mentioned the dual polarity radar stuff. If that smoke actually gets close enough to the ground to be picked up by the radar, that's going to also be, the below 80 value for the correlation coefficient that I mentioned earlier. So you'll actually see this blue plume going across. A number of years ago, I was watching Channel 3, and Kate Bilo was saying how there's this big snow streamer coming off. It was winter time, and they're like, yeah, look at this big snow streamer. It's like, okay, now I'm looking at the correlation coefficient, and that's telling me it's not snow. And at the time, I think they're better about it now, but at the time, the TV folks still hadn't figured out how to work the correlation coefficient into what they look at. So what it actually was a big, I think it was a tire warehouse fire or something, and it was putting out an amazing amount of smoke, and it was showing up on radar. But with the dual polarity, you can figure that out pretty quickly. I know that was an aside, but hopefully that was interesting. So anyway, I guess I'll If no one has any other questions, I'll hand it back to Jeremy. Go ahead.
All right, let's thank Lou for his presentation. Great job with that.
It was great.
Actually, I see Dick has joined us. Did you want to say anything about the upcoming VE session?
Yes, as a matter of fact, it's going to be Saturday, November the 5th. We already had 3 candidates signed up, 1 tech, 1 general, and a third person that's committed to take tech and general.
All right.
So, and usually we get another 3 or 4 as we get closer to Saturday, November 5th. It's going to be in person at the Lower Providence Township Building in Eagleville, Pennsylvania. Starts about 9 o'clock in the morning, and we're usually done by 11 o'clock. So I'll be putting out an email to the VE team, looking for several volunteers to help me out that day. Thank you, Jeremy.
All right.
Map and
Thanks,
rules
Dick.
on the website too.
You doubled there. Well,
I
Dennis?
was saying the map for the site and the testing rules are on the website.
Correct. I put that in my letter of my confirmation letter that I send to each of the candidates.
All right. So does anyone else have any other items for the meeting? All right. If not, we will adjourn the meeting. So we will see you again. We have the breakfast coming up on November 12th. We have a couple of public service events coming up October 30th and November 5th. We have the VE session, which will be on November 5th. And our next meeting will be November 22nd, a Tuesday, right before Thanksgiving. So we'll see you very soon. And of course, we also have the Nets every Wednesday and every Sunday, 8:30 p.m. on 147.06, 145.13, and 445.675. So we will see you around, either on the Nets, at a meeting, or one of our other events. Take care.